I like not having a green screen because it means I can wear a green shirt without disappearing. It's fantastic. And I really like this shirt. And thanks for watching. And Otto thanks you as well. In 1943, Los Angeles experienced its first major smog event. It reduced visibility to 3 blocks and caused widespread respiratory issues. California's geography traps air pollutants, and its warm climate promotes ozone formation. Transportation accounts for 80% of smog-forming nitrogen oxides and half of greenhouse gas emissions in California. In response, the California state government established the Air Resources Board in 1967, which pioneered air quality legislation. The zero-emission vehicle mandate was introduced in 1990 as a part of the low-emission vehicle program addressing transportation pollution. It initially required 2% of vehicles sold by major automakers to be ZEVs by 1998. The mandate was deliberately technology forcing, pushing innovation when EV technology was still immature. It's had multiple modifications over decades, meaning they want all vehicles sold by major automakers to be zero-emission vehicles. The General Motors EV1 originated from the Impact prototype unveiled at the 1990 Los Angeles Auto Show. This is what the EV1 looks like plugged into a charger. And here's a basic schematic of the vehicle. And here's what the interior of the vehicle looks like. GM developed the EV1 specifically in response to California's zero-emission vehicle mandate. So this was directly in relation to the smog in Los Angeles. The actual launch was in 1996. The EV1 is regarded as the first mass-produced electric vehicle designed from scratch by a major automaker, which was purpose-built. It featured advanced technology, including a 3-phase AC induction motor and regenerative braking. It initially had a range of 70 to 100 miles with lead-acid batteries, but it was later upgraded to 160 miles with nickel metal hydride batteries. The design of this vehicle led to innovations still relevant today. GM ultimately canceled the program and controversially crushed most of the vehicles, citing that it was not economically viable. They initially released it on lease. Approximately 40 units were donated to museums and educational establishments. And interestingly, 5 EVs were reported to be donated to China in 1998. The demise of the EV1 is well documented. Around the same time, a company called AC Propulsion created a prototype called the tZero, a groundbreaking electric sports car developed by Alan Cocconi, founder of AC Propulsion and a pioneer in EV technology. This is what the tZero looks like. Interestingly, it had a range extender, which was basically just a trailer with an internal combustion engine powered generator. It was just mounted on a trailer that could be towed behind the car and feed power to the batteries during travel. This is what the trailer looks like being filled. A pretty interesting solution. It was initially developed using lead-acid batteries, similar to the EV1, and it offered 85 miles of range in its original configuration. Over a 6-month period, the tZero was converted to lithium-ion batteries 7 years after its launch in 2003. And Cocconi assembled the new battery pack using 6,800 small lithium-ion cells, which reduced the weight by 500 pounds. This upgrade achieved a remarkable 300 miles range, a 253% improvement, while significantly improving acceleration. Martin Eberhard provided financial support for the lithium-ion conversion after recognizing its potential for high-performance EVs. Commercial plans were abandoned in mid-2003 due to high costs. So there was significant demand at the time. And Eberhard borrowed the converted tZero for 3 months as a daily driver to demonstrate it to potential investors. And Eberhard went on to co-found Tesla Motors in 2003, to pursue building electric sports cars. And this innovation is the direct technological lineage from the tZero to the Tesla Roadster, which established the foundation for modern performance EVs. And what the Tesla Roadster did was it built upon the tZero, the customized tZero, and was introduced in 2008, roughly 5 years later. What the tZero proved when it was equipped with lithium-ion batteries was that you could use this to propel a vehicle with viable performance. So they took something that was already being used in something like a laptop and applied it to the tZero, because lithium-ion batteries were already being used at that point, and it took until 2003 to take the lithium-ion battery and apply it to a vehicle. And that's the interesting thing, is they took that tech and reapplied it to something else and saw a significant improvement. What the Tesla Roadster did was it refined the tZero. It successfully commercialized by leveraging existing Lotus Elise chassis designs to reduce the developmental cost. If you look at the Lotus Elise and then you look at the Tesla Roadster, they look very similar. So the Tesla Roadster took these pieces and put them all together and proved that this technology could be commercialized. And the Tesla Roadster marked Tesla Motors' entry into the EV market and laid the foundation for future industry transforming models like the Model 3. The key technological innovation behind this transition was the lithium-ion battery. The Tesla Roadster perfected the lithium-ion implementation using modular laptop cells that balance cost, performance, and manufacturing scalability, mass production. Here is a table clearly outlining the comparison between the General Motors EV1, the AC Propulsion tZero, and the Tesla Roadster. The conclusion from this recognition is that California's zero-emission vehicle mandate was pivotal in forcing technological advancement when market incentives alone were insufficient. They had to find a different way to achieve the same performance without producing emissions. And that's what they did. General Motors produced the EV1, AC Propulsion produced a prototype, and then Tesla's Roadster made it mass producible. And these are my sources for the video.